Question 7 is about the crane, and we have to explain why the crane needs to be counterbalanced. Well, if the support tower is the pivot, then the moments need to be balanced or equal on either side of that pivot. If it wasn't, then the crane would topple over, or there'd be a very large strain on the supporting tower itself. Part B. It says in the question that the crane is balanced and we have to calculate the size of the moment. We use the equation moment equals force times perpendicular distance from pivot. If we look at the size of the force and the distance, we can put in the values. So we've got 10,000 newtons and we've got 40 meters, giving us 400,000. Now we must include the units in this question. This is where a lot of students slipped up. Force newtons multiplied by distance in meters gives us Newton meters. Part 2 of this question, we've already been told that the crane in the diagram is balanced. So if we've got 400,000 Newton meters on one side of the pivot, then we must also have 400,000 Newton meters on the other side of the pivot. So that's our starting point. The distance is equal to the moment divided by the force, gives us 400,000 divided by the force 50,000, which will give us 8 meters, and you must include the units, meters.